In this video, we're solving a system of linear equations by applying Cramer's rule. Now, Cramer's rule involves solving the system with determinants. So this allows us to solve the system without rewriting x's and y's. So this method is advantageous specifically when we have systems of equations containing decimals, perhaps, or even scientific notation, because we wouldn't want to rewrite a lot of our numbers, especially if the decimals consist of many, many digits. So first, we take the determinant of the coefficients, 4.12, 7.65, negative 2.99, 7.50. Again, notice how I couldn't apply the elimination method, for example, since I can't readily determine if there's a number I can multiply by 2.99 to give me 4.112 and eliminate those x's. And substitution would just be really, really tedious because I'm rewriting a lot of digits, a lot of decimals. Good. So to evaluate the determinant of a 2x2 matrix, I do A times D minus B times C, which gives negative 22.9. And this equals about 53.8. Good. Now I find dx. Now this is counterintuitive, but if I'm finding the determinant associated with x, I replace the x column with the right-hand side constants. So negative 18.3, 1.32. However, my y column remains my y coefficients. Good. Now A times D, negative 18.3 times 7.50. Negative 137.25 minus B times C, which is 10.1. This gives negative 147.35. Now, even this would be really tedious. I'm rounding some of these decimals, by the way. So for example, the 10.1, my calculator actually gave me 10.098. So I'm just trying to keep around 3 digits if I can. Good. Determinant associated with y. My x column is my x coefficients. My y column gets replaced with my constants. A times D. So I did 4.12 times 1.32 minus B times C, 54.7. This equals negative 49.3. Finally, the last step of Cramer's rule, x equals dx over d. Again, dx was negative 147.35, all divided by 53.8. This is approximately negative 2.74. So this is x. And now y equals dy over d. dy was negative 49.3 over the determinant of the coefficients, 53.8. So y is approximately equal to 0.916. Excellent. So this is how you apply Cramer's rule.